Okay, talking about parabolas today. We're getting into conics. Okay, a parabola, a set of all points P, okay, that are the same distance from a fixed point F, like right here, that they are from a fixed line called the directrix, okay, which is D. Okay, so here's an example. Okay, here's a parabola. Here's my focus. Here's my fixed point. Let's just say I've got this distance here. The distance from this fixed point, the focus, to any point on, but let's just pick this point here. That distance here equals the same distance as perpendicular distance to this line called the directrix, okay? If I pick this point here, the distance from here, from the focus to any point here is the same distance to that line, the directrix, okay? So this isn't perfect, I sketched this, but that's the parabola, okay? It's a set of all points that are the same distance from a fixed point F as they are from a fixed line, the directrix, okay? So let's take a look at some of our components. Here's the vertex of the parabola. I've got a smile and a frown to start off with. Parabolas that are kind of symmetric about the y-axis. And right now my vertex, I'm starting off with easy ones with the origin. 0, 0 is my vertex. Okay, so the vertex, when you're going up or down, is the bottommost point or the topmost point. And the axis of symmetry, in this case, goes right through it. Our axis of symmetry is x equals 0, or the y-axis, okay? The axis of symmetry, of course, this parabola is symmetric about the axis of symmetry. The axis of symmetry goes through the vertex, and it's perpendicular to this line called the directrix. The directrix is perpendicular to the axis of symmetry. All right? Notice the parabola always wraps around the focus, this point called the focus, okay? All right, we said the directrix, we talked about, that's this line that any point is the same distance as it is, this line is the same distance from any point as those points are to the focus, okay? Talked about vertex, focus, the directrix, axis of symmetry. All right, for vertical, there's different formulas. Some books use y equals x squared over 4a. The book I'm using has it x squared equals 4ay. That's kind of the general equation for a smile, okay? The smile parabola. Okay, we've got something else. It's kind of a funny name called the lattice rectum. Okay, I know that's funny. The line segment joining points 2a and a and negative 2a and a. So that's, what does that mean, the lattice rectum? Okay, on a vertical type smile type parabola, here's my focus. Okay, if I draw a line perpendicular to the axis of symmetry that connects these points that go through the focus, that's my lattice rectum. And it always has a distance, the lattice rectum, LR we'll call it, has a distance of 4a. What's A? That's a good point. A is the distance between the focus and the vertex, and A is also the distance from the vertex to the directrix. So my focus is 0.04, that distance is 4, okay? All right, so right now my focus is coordinate, I don't know if you can see that, 0, A, okay? Because that distance is A, right? We're 0 on the x-axis, my y-coordinate is A. It could be 0, 4, okay? 0, 4, all right? In that case, okay? So we'll talk more about, we like to help us manually graph. It's nice to get these points, okay, on that we can graph through and find out what these points are. So let's take a look at how we go about doing that, okay? Big thing vocabulary-wise: vertex, focus, directrix, axis of symmetry, lattice rectum. That's the line that's going to go perpendicular to the axis of symmetry that connects the points if we go through the focus, okay? All right, let's take a look. Okay, so here's that same parabola we were dealing with, okay? Here's our lattice rectum connecting these points through the focus, okay? All right, here's my distance. I'm on the vertex is the origin, 0, 0. Here's my directrix. Notice the distance is a. Okay, so here's my formula. X squared equals 4ay. Notice, if I want to find out what my x coordinates are, I'm going to plug into x squared equals 4ay. I'm going to plug in y. I know what a is, let's say. Okay, we know a is some distance. And if I want to get what my x components are here, I'm just going to plug in a. So 4ay ends up being x squared equals 4ay ends up x squared equals 4a times a, right? This is my y component, okay? Well, that's 4a squared, okay? It's 4a squared, all right? So if I square root both sides, my x component is plus or minus 2a. So notice, remember I said the lattice rectum, this whole distance is always 4a, so this part will be 2a and this part's 2a. So this component here is going to be 2a comma a, 2 times a, and what's my y component? A, this focus is 0.0a, right? And this is just negative 2a, remember? This is just going to be on the negative side. This point is negative 2a, okay? We'll do one and it'll make more sense, okay? All right? We basically know what this point is, and then we plug it in this equation. And you don't even, and we can do this without doing all this, but you can plug in what your y value is, and we can solve for all these. We can solve for we can solve for this once we work an actual problem here. All right. Now here's the formula. We'll get, anyway, I don't want to confuse you. We'll get to work a problem and make more sense, okay? Bottom line is we know this distance here, and whatever that is, this distance from here to here is twice that on either side. So if this is 2, this will be 4 over here, and this will be negative 4 to this side from the origin, okay? All right. The formula for the frown is just going to be negative. Notice how we always wrap around the focus. Here's my vertex, the origin, 0, 0. There's my vertex, okay? Here's my directrix. It's always perpendicular to this axis of symmetry, and this equation is y equals a, whatever this distance is. If that is 4, this is y equals 4, okay? This focus would be, if that's a is 4, this focus, 0 comma negative a, is 0 comma negative 4, okay? Just hypothetically, okay? All right, the equation for the frown, it just has a negative. X squared equals negative 4ay, okay? All right, so the positive, the smile is x squared 4 equals 4ay. The frown is x squared equals negative 4ay. All right, now let's talk about horizontal parabolas. Now it's y squared equals 4ax. Okay, notice here's the focus. In the positive side of the x-axis, my vertex is the origin right now, and we can switch the origin. Right now I'm keeping it simple. Notice my distance here between the origin and my focus is the distance a, and the distance from the vertex to the directrix, here's the directrix. It's perpendicular to the axis of symmetry. This is going to be a x equals equation, right? Vertical lines are always x equal. Well, this will be x equals negative a. Remember, these distances are the same. This distance is a, this distance is a. The vertex to the focus equals the vertex to the directrix, which is a. But if I go a in the negative direction, this is going to be negative a. So my equation for the directrix is x equals negative a. If I, over here, the focus is, here's my origin, 0, 0. Right here. So this point here is a comma 0. If that distance a is 4, then that would be 4 comma 0 for the focus. All right. Remember, here's my lattice rectum again. I'm connecting the 2 points that are on the parabola by going perpendicular straight through the focus, perpendicular to that axis of symmetry, okay? So remember, I know that the whole distance from the lattice rectum is 4a, 4 times a. So this is half of that, that's 2a, and this is half of that, that's negative 2a, okay? So this ordered pair would be a positive 2a and a negative 2a, okay? We kind of work that out. Here's the equation. Here's a parabola that opens up on negative territory. Notice I wrap around the focus, and that's going to be y squared equals negative 4ax. Okay? Y squared equals negative 4ax. Vertex, all the same components, okay? All right. Let's work this problem here real quick. 10 minutes. Focus is 3, 0. Vertex is 0, 0. Let's get an equation for the... Okay, so here's my vertex. The focus is 1, 2, 3, 3, 0. Okay, so I know this is a horizontal type parabola. Okay, it's going to open up this way. 1, 2, 3. This distance A is 3 units, so I'm going to go 1, 2, 3 on the other side. And what's that? That's my directrix. It's going to go through negative 3. Here's my directrix, which is going to be x equals negative 3. X equals, okay? This focus is 3, 0, right? The equation of the parabola is going to be y squared equals 4ax. Well, a is 3, right? That's my distance, 1, 2, 3. So y squared equals 4 times 3 x equals, so y squared equals 12x. That's the equation of the parabola. Now let's find our latus rectum, and I want to get these points, okay? All right. Remember, this distance here is 2a, and this distance here is going to be 2a in the negative territory, okay? Remember, because we get y squared equals, what I'm going to do is what? Is 4, y squared equals 4 times a times x. Well, what's x? X is a. That's a times a, which is 4a squared, and we square root both sides, and y equals plus or minus 2a. And we know that what? A is 3. Okay? A is 1, 2, 3. So my y component with an x of 3, right, is plus or minus 6. 2 times 3. So my 2 points are 3, 6 and 3, negative 6. Okay? So that's my 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So that would be the points that I can kind of draw through and shape my parabola. Another way of doing that is once you get this equation right here, once I get that equation of y squared equals 4ax, y squared equals 4 times, we figured that was 12. We know a is, a was 3, so that's 12x. We've got this equation. Well, we want to get the points on the latus rectum. We want to plug in 3. You plug in the coordinate for the focus. Y squared equals 12 times 3, which is 36. And I square root both sides. Y equals plus or minus 6. Okay? And that's how I can get this. So that's kind of us working equations. The big thing is, here's your formulas for smile and frown is x squared equals 4ay, x squared equals negative 4ay. If they're horizontal, it's y squared equals 4ax, and y squared equals negative 4ax. And we've talked a lot about vertex, focus, directrix, axis of symmetry, latus rectum. That's the line from connecting the 2 points in the parabola when we go through the focus, okay? And we're always perpendicular to the axis of symmetry, directrix, and so on. All right, that's all I have. Hopefully you guys picked up a lot of this stuff and we can work some problems, okay? All right, see you tomorrow.